With advancements like the Da Vinci robot and others of its kind, laparoscopic surgery has revolutionized precision of basic surgeries and patient recovery time. Though these robots can give surgeons an adequate visual sense of the internal environment, taking force data of internal tissues has yet to become a practical diagnostic tool. The goal of our project was to construct a tactile imaging probe for tissue diagnostics.
This was done by combining data from a 3D scanner and a force sensor to create one tactile model, which could be virtually touched by diagnosticians.
Our 3D scanner design featured a standardized calibration backdrop visualized by a high-definition webcam.
The circular sample plate in front of the backdrop could rotate to incorporate multiple angles of the target object.
All pieces were cut and mounted to the plastic base shown here. The robotic arm is the Phantom Omni, which was used later for force testing. Mounting brackets for the Omni were designed using SolidWorks and were constructed using a 3D printer in the undergraduate fabrication lab.
We then tested the force sensor using 3 different mouse tissues. You can see on the computer's display that the soft liver tissue yields larger magnitude spikes than the more firm skin tissue.
Next, we connected this force sensor to the Phantom Omni device. Due to our use of biological samples, we created a custom latex sleeve to protect the device.
This is our full data acquisition setup. On the left, you can see the backdrop and laser line used for scanning. The Omni is positioned over the sample tray, ready to take force data. A power supply for the force sensor and a laptop for compiling the data and constructing models is shown on the right.
We will now take you through the data acquisition process for the skin tissue sample.
And here's the finished product, a plot of force vectors associated with locations on a 3D surface mesh.
This data was then used to create a tactile model as seen here, with different colors representing different surface properties. Open haptics technology can be used to virtually touch this surface.